Hi friends, in this session let me discuss about the pneumatic braking system, so which comes under the different types of brakes. So already we have discussed about the hydraulic brakes, so which actually works based on the hydraulic fluid. So here we're gonna have the pneumatic as a medium for applying the brakes. So this is a general brake line. So we're going to discuss with the help of these line diagrams, so it will be much easier to understand. So before we go into the brake lines, we need to discuss about why do we need an air brake system or pneumatic brake system compared to the hydraulic brakes. What are the advantages of having a pneumatic brakes? So actually hydraulic brakes are more efficient compared to the pneumatic brakes. So but because the hydraulics are incompressible fluid, so we can actually have more thrust on them compared to the pneumatics. So if we have any leakages, then the pneumatic brake has a failure. So for example, if you have a truck or a heavy equipment vehicle, it actually needs a much higher force of much higher brake force to stop your vehicle or slow down your vehicle. For example, if it's a 15 ton or the 20 ton vehicle, so it needs a higher pressure of force, so it has to be used to stop your vehicle. So to have a much higher force of braking force, so you need to have a larger storage tank of larger hydraulic fluid storage tank. So due to those constraints, we've been moving to the pneumatics where the air could be compressed and stored in a air tank. So it is much easier, and so this air is abundantly available in the atmosphere, so that you can take it from the atmosphere, compress it and store on your air tank, and you use for your braking application. So here let's discuss about the components of the pneumatic brakes. So it's a foot valve. When you press your foot valve, so from this foot valve the brake, the air will be dispatched to the both brake chambers of the front wheel and the rear wheel brake chambers. So we have a compressor to compress the air. So this runs the help of your engine. So you have a governor to govern the compressor. You have an air dryer to tray the air. So from then it goes to the storage tank. So you'll have a primary storage tank and the secondary storage tanks. So this goes to the rear and this goes to the front wheel, and you do have the parking brake. So let's discuss them in detail. So this compressor has been running, which runs based on your the engine. From your engine, the compressor has been connected with the help of your cam. Then this compressor tends to compress the air from the atmosphere, suck the air from the atmosphere, compress it, and send to the air dryer. So when it compresses and sends to the atmosphere, the compressed air has some moisture. So this moisture has to be removed. So this air dryer has a desiccant. So this desiccant actually filters the water or the moisture content which has been present in the air, and the pure air will be sent from the air dryer to the storage tank. So this storage tank is been used to store the pressurized fuel. Basically this storage tank for a normal case of a bus or a truck, the air tank capacity will be around 8.5 bar. So probably the braking pressure actually we need to keep in mind, which is very important. Basically the pressure will be nearly about 6.5 to 8.5 bar, so for each braking cycle. So this storage tank will be having a maximum of 8 to 8.5 bar of a pressure. So when the air from the air dryer gets into the air compressor, so the air gets compressed and stored in the air tank, which is equal to 120 psi. So it tends to store. So then it goes to the primary and secondary. So those will be stored at the same 8.5 or 120 psi. 8.5 bar or 120 psi. So once you press your foot pedal, this is a foot pedal valve. So when you press your foot pedal valve, so the compressed air which has been stored in the primary tank and the secondary tank, so the air rushes towards your relay. So you'll have the front relay and the rear relay. So from the relay, so when it pushes your the spring, so the relay spring, therefore the air gets into the both brake chambers. On your brake chambers, you'll have a diaphragm members on the both sides of the brake chambers. So the diaphragm pressures the slack adjuster. So this is your diaphragm. So the air gets into the air chamber. So when it gets into the air chamber, the diaphragm pushes the slack adjuster, which has been pushes with the help of a push rod. So the slack adjuster moves. When the slack adjuster moves, the S-cam, which has been connected on your brake drum, tends to rotate. So when it rotates, it actually extends your brake shoes, and due to this frictional force, the brake gets stopped. So when you press your foot pedal, so the brake, the fluid, the pneumatic air, the compressed air gets into the brake chamber with the help of these relays. So this is like you have when you press your foot pedal and release, so the air from the brake chamber gets out of this quick relay valve. So you'll have some quick release. So that's why when you press your foot pedal and release it, you'll have some hissing noise. So that's the release of the air, compressed air from the brake chambers, that is getting out towards the quick release valve. So that's how this actually works. So when you press your foot pedal, so the air from the both primary and secondary storage tank gets towards the braking lines, and from the relay valve it goes to the braking chamber. So this braking chamber actuates your S-cam with the help of the push rod. So each time when you apply the brake, so the pressure gets dropped down. So when the pressure gets dropped down, actually the compressor starts again. So you have a governor, so it stops the loading cycle of your compressor when the storage tank gets filled up. So when it reaches the maximum pressure, the air tank reaches the maximum pressure, this governor senses and cuts off the loading cycle. So the compressed air goes to the governor, and where you'll have unloader. So this unloader releases the air towards your compressor, and the air gets circulated inside the compressor, so there won't be any loading. So when the air which is being used for the brakes, so the air pressure gets dropped down. So when the air pressure gets dropped down, the governor senses signals the compressor to start again. So due to this pressure difference, the compressor starts again, and it tends to load the air tank. So each time when you apply pressure, so the brake, the pressure actually varies from 6.5 to 8.5 bar. When you're going to apply the parking brake, so you release your the total air pressure inside the cylinders, the air tanks. So that's why when you have been seeing on few transport, the public transport, so while applying or while stopping the vehicle, they release the total air inside the air tank. So this actually enables the springing brake. So this spring brake will be released when the storage air is being taken out. So it is been when the storage air is being released, the spring brake get actuated and holds your the brake components. So it means that the spring brake gets actuated, and the brake line or the brake drums gets in contact with the drum, so that the vehicle doesn't move. So this is how the parking brake actually works. So when you need to release the parking brake, so you have to start your engine and you have to compress it until it reaches the 8.5 bar of pressure, so that this air is being able to release the spring brake, so that the brake is being released. So this is how the pneumatic brakes actually work. So this is a simple explanation, but there is few more explanation. This is a basic brake line, so it varies with respect to different segment of braking. So this is like a 6-wheeler, so you have a trucks, you have a trailer, and the tractor. It actually varies. So this brake line actually, but the concept remains the same. So if you have any doubt, you could ask me through the module. I will explain you. Thank you guys.